Have you ever wondered how towering skyscrapers and sturdy bridges come to life? Behind these marvels of engineering lies a ubiquitous, yet often overlooked material: cement. Cement is the binding force in concrete, the most widely used building material on the planet. But where does this crucial ingredient come from? The answer lies in the intricate workings of a cement factory. This essay takes you on a journey through the complete cement factory process, from the arrival of raw materials to the dispatch of the final product. We'll delve into each stage, unraveling the technical intricacies and shedding light on the crucial role of quality control and efficiency. Whether you're a construction enthusiast or simply curious about the world around us, join us as we explore the fascinating process behind this essential building block of modern civilization. Before we delve into the step-by-step process, let's familiarize ourselves with the key components of a cement factory. These massive industrial complexes are a marvel of engineering, housing a series of interconnected units that work in unison to transform raw materials into the fine powder we know as cement. At the heart of the factory lies the kiln, a massive rotating furnace that reaches temperatures high enough to melt rock. The raw materials, primarily limestone and clay, undergo a dramatic transformation inside this inferno, fusing together to form clinker, the intermediate product in cement production. Other essential components include grinders, used to pulverize raw materials and clinker, blenders, responsible for achieving the precise mix of ingredients, and storage silos, where raw materials, clinker, and finished cement are stored. The journey of cement begins with the extraction of raw materials, primarily limestone, clay, and sand, from quarries often located near the factory. These materials are transported to the factory, typically by trucks or conveyor belts, marking the beginning of the cement production process. Upon arrival, the raw materials are carefully inspected for quality and composition. Each material is then transported to designated storage areas within the factory complex. Limestone, the primary ingredient, is usually stored in large open yards, while clay and other materials are kept in enclosed sheds to protect them from the elements. Proper storage is crucial to maintain the quality of the raw materials and ensure a smooth and efficient production process. This stage also involves careful documentation and tracking of material quantities to ensure a constant supply for cement production. Once the raw materials are safely stored, the next step is blending them in precise proportions. This stage is crucial because the final properties of the cement, such as its strength, setting time, and durability, depend largely on the composition of the raw mix. Cement factories use sophisticated computer systems to calculate the optimal mix based on the desired characteristics of the final product. The blending process involves feeding predetermined quantities of each raw material onto conveyor belts that transport them to a central blending silo. Here, the materials are thoroughly mixed to ensure a homogeneous blend. This meticulous process is continuously monitored and adjusted to maintain the consistency and quality of the raw mix, which is essential for producing cement that meets stringent industry standards. Grinding into powder, preparing the raw mix. With the raw materials blended to perfection, the next step is to grind them into a fine, powdery substance known as raw meal. This crucial step increases the surface area of the materials, facilitating the chemical reactions that will occur during the burning process in the kiln. The raw mix is fed into powerful grinding mills, massive rotating drums containing steel balls or rollers. As the mill rotates, the balls or rollers crush the raw materials against the inner walls, gradually reducing them to a fine powder. The fineness of the raw meal is meticulously controlled, as it directly affects the efficiency of the subsequent burning process and the quality of the final cement. The fiery transformation, turning powder into clinker. The heart of the cement production process lies in the kiln, a massive rotating furnace that subjects the raw meal to intense heat. Inside the kiln, temperatures reach up to 1,450 degrees Celsius, causing the raw materials to undergo a series of complex chemical reactions. As the raw meal slowly travels through the rotating kiln, it is heated in stages. First, any remaining moisture is driven off. Then, the heat breaks down the raw materials into their constituent oxides. Finally, at the hottest part of the kiln, these oxides combine to form a new material, clinker. Clinker emerges from the kiln as small, grayish-black nodules, marking a significant transformation in the cement production process. Cooling down, preparing clinker for final processing. After its fiery journey through the kiln, the red-hot clinker needs to be cooled down rapidly to prevent the formation of undesirable compounds. This is achieved using clinker coolers, specialized heat exchangers that use air to cool the clinker from around 1000 degrees Celsius to a manageable temperature of around 100 degrees Celsius. The cooling process is not merely about reducing temperature, it also plays a crucial role in determining the final properties of the cement. Rapid cooling helps to preserve the desired crystalline structure of the clinker, which directly influences the strength and setting time of the cement. Once cooled, the clinker is ready for the final stage of its transformation into cement. The cooled clinker is now ready for its final transformation into cement. This stage involves grinding the clinker with a small amount of gypsum, which helps regulate the setting time of the cement. The grinding process takes place in ball mills, similar to those used for grinding raw materials, but with even finer control over particle size. The resulting fine gray powder is what we know as cement. The fineness of the cement is carefully controlled as it directly affects its workability, strength, and hydration properties. Finer cement particles offer a larger surface area for reaction with water, resulting in faster setting times and higher early strength. From factory to construction site, packaging and distribution. The final stage of the cement factory process involves packaging and distributing the finished product to construction sites and concrete plants. Cement is typically packaged in bulk bags or paper bags depending on the quantity required and the transportation method. Bulk cement is transported in specialized tanker trucks, equipped with pneumatic systems for loading and unloading. Bagged cement, on the other hand, is loaded onto trucks and transported to distributors or directly to construction sites. Proper packaging and handling are essential to protect the cement from moisture and contamination, preserving its quality and ensuring its optimal performance in construction applications. The unsung heroes, management and administration in cement production. While the technical processes within a cement factory are undoubtedly fascinating, we must not overlook the crucial role of management and administration in ensuring the smooth operation of these complex facilities. Behind the scenes, a dedicated team of professionals works tirelessly to oversee every aspect of the cement production process, from procurement and inventory management to quality control and logistics. They are responsible for optimizing production schedules, managing resources efficiently, and ensuring that the final product meets the highest quality standards. Moreover, they play a vital role in ensuring the safety of the workforce, adhering to environmental regulations, and maintaining the overall profitability of the cement factory. Keeping the wheels turning, logistics and transportation in a cement factory. The efficient movement of materials and products within the cement factory and beyond is crucial for maintaining a seamless production process. This is where logistics and transportation management comes into play, ensuring the timely delivery of raw materials, the smooth flow of intermediate products between different stages of production, and the efficient dispatch of finished cement to its final destinations. This involves coordinating multiple modes of transport including trucks, conveyor belts, and potentially rail or even ships, depending on the factory's location and distribution network. The logistics team also plays a crucial role in optimizing loading and unloading times, managing inventory levels, and minimizing transportation costs, all of which contribute to the overall efficiency and profitability of the cement factory. Cement, the foundation of our built environment. From the towering skyscrapers that define our cityscapes to the bridges that connect communities, cement is the invisible backbone of our built environment. Understanding the intricate processes involved in its production provides a newfound appreciation for this ubiquitous material. As we have seen, the journey from quarry to construction site is a complex and fascinating one, involving a delicate balance of science, engineering, and human ingenuity. The next time you marvel at a concrete structure, take a moment to recognize the crucial role played by the humble cement factory and the dedicated individuals who work tirelessly to produce this essential building block of modern civilization.